Yeah, and my name is Kai-Hsun, and very happy to have a chance to present here. And today I will talk about build a RAG-based large language model application with Ray and KubeRay on Kubernetes. Yeah. And this is some of my metadata, and you can see this is my GitHub handle. And I'm currently a software engineer in the Ray core team in the Anyscale, and primarily focusing on the KubeRay, and in this year also work on some Ray core stuff. And I pretty like to work on open source since I was a student. And I work on like a Ray, KubeRay, Apache Submarine, Apache Spark, and some engineering stuff. And I contribute to them and also maintain some of these projects. And I spend a lot of my spare time that's promoting the open source that's in Taiwan. I mentor about 10 people to become the Apache Software Foundation committers, and mentor 2 people that to become the top 8 KubeRay contributors, and build a community in Taiwan to help more than a lot of people to work on join the open source community, and more than 5 people that's become the Apache Software Foundation and Linux Foundation committers at this moment. So if you are an open source lover, feel free to just reach out to me, and we can talk about open source. Yeah, and the first is that I will introduce the large language model and the RAG. Yeah, I think in the past 1.5 years, large language model is almost everywhere because it showcases that it has the human level capability. So open up a lot of the new AI application opportunities. Yeah, but one of the challenges for the large language model is that if we ask the question that it's not in the training data of the model, of the foundation model, it cannot give you a correct answer. And to solve this, we can use the fine tuning or use the RAG. RAG is a very popular solution, and the idea is that we can put the context, generate the embedding for the context, and put in the database. And then when we send the query to a large language model, we can at first to retrieve the context from the database, and also append the context that's in our query. So we can get so the model can learn the knowledge that's from the context that we provide. Yeah, and because we will demo a RAG application that's with Ray and KubeRay. So before that, I need to introduce what is Ray and KubeRay. Yeah, I think AI is all around you. For example, I take the Uber almost every week, and I use ChatGPT to help my daily work. And our company that order a meal from the DoorDash every day. Yeah, so I think AI is all around our life, and all of this company use Ray to build their ML infrastructure solution. And I would say that most of them deploy Ray with KubeRay on the Kubernetes. Yeah, so now we currently know who use Ray, and now we can talk about why do we need to use Ray and what is Ray. Ray is an open source computation framework that is for scaling the AI and the Python applications. And you can think this is kind of the computation framework. You can think it's similar to like a Spark and something like the MariaDB before. And why do we need to use Ray? I think the first point is that Ray is pretty easy to use. I think maybe most of you learned what is MariaDB that in your undergrad operating system course or distributed system course. If you want to parallelize your program with the MariaDB framework, you need to rewrite it into a map function and a reduce function. And I would say that it is pretty hard. And I believe that I have I'm able to say this because I published some paper about MariaDB before. Yeah. So, but with Ray, Ray is pretty easy to use. You just need to modify several lines of code. And so your local program will be almost the same as the distributed system version. And I will showcase it later. And the second is that Ray is pretty general purpose. You can think like a Spark is designed for data processing. So the abstraction is something like the Spark data frame. But Ray is designed for the general programming. So you can almost do anything with Ray. And ML workload is a very special workload because it is very, very versatile. It includes like a data processing, training, tuning, and serving. So you need to have a computation runtime that can cover the end-to-end life cycle. So Ray can support any workload, any hardware, on any cluster, and at any scale. And you can see in this image, you can see the Ray core. Ray core is the core computation engine. The Ray community built several AI libraries based on the Ray core, including like the data, train, tune, reinforced learning, and the serving. And we can deploy the Ray on the we can deploy on like a public cloud like the AWS, GCP, and Azure, and we can also deploy on Kubernetes cluster or deploy on your on-prem cluster. Yeah. So now we will introduce the first is talk about the Ray core in this slide. You can think about what are the essential components that's for your local program. I think there are 3 components. One is you need to write a function, you need to define the class, and you need to define the variable. And as I told before, like Spark designed for the data processing, and the Ray is designed for general programming. So Ray has a one-on-one mapping with the registry abstraction. So for example, like we have a Ray task, which is the remote function, and we have a Ray actor, it's a remote class, and we have object, it's a remote variable. So because it is a one-on-one mapping, it can do almost anything, and the actor and the task can communicate with each other, and you don't need to worry about like which node that this task is running on, and which node is this actor running on. So you can think Ray enable you to just program in the distributed cluster, maybe on 100 or thousands of nodes, just as if that you are working on your laptop. So Ray's slogan is that it is an infinite laptop. Yeah, so and this is the example to showcase how easy it is for the Ray core. I pretty like this simple example. This example is from a user that's from a traditional bank in Taiwan, and he is a data engineer, and he needs to handle a lot of CSV file almost every day, and he used Ray as their parallelized computation solution, and you can see how easy it is. We just add an annotation to convert the function to become a remote function, Ray task. And then we change the master to a function code to call the remote is the way to call the Ray task. So that's all. It's pretty easy to scale up to like 1,000 of the CSV files in this use case. Yeah, and now we know what is the Ray core. So we can talk about Ray AI libraries. The Ray community built several Ray AI libraries based on the Ray core, including like the Ray data, Ray train, Ray tune, and the Ray serve, to cover the end-to-end model lifecycle. And for the Ray data, it's primarily for like data loading and like the batch inference or like embedding generation. And Ray train is for the distributed training, and the Ray tune is for the hyperparameter tuning, and the Ray serve is for the online inference. Yeah, so now currently we know what is a Ray core and the library that built based on the Ray core. So we currently can talk more about the deployment solution. In the Ray, we support 2 kinds of the deployment solution. One is on the virtual machine, and the other one is on the Kubernetes. And KubeRay is the official support that's from the Ray community to support to deploy Ray on Kubernetes. And I would say that most of the users deploy Ray on the Kubernetes by KubeRay. And I'm not sure how many of you that have the context about Kubernetes or have the experience. If you have experience about Kubernetes, you may know the Kubernetes operator. And KubeRay is a Ray Kubernetes operator. And the goal of this project is that we want to separate the 2 kinds of the user. The one is the data scientist to focus on their computation, focus on the Python script. So they don't need to worry about how to build a Docker image and how to write YAML files. And the other side is that for infra engineers, we want them to focus on the infrastructure stuff, like the monitoring, like a Prometheus, Grafana, like a frame bits, and like to set up like the ingress, like an Nginx. Yeah, so currently we know Ray and KubeRay, and we can take a step back. We can revisit that what some of the existing solution that I think most of the applications that on the Kubernetes cluster are built by in a microservice architecture. So I think in most cases, I think a microservice architecture makes sense for some infrastructure stuff, but it is not make sense for some computation stuff. For example, because ML workload is very versatile, as I talked before. It covers like if you need to do a data processing and some feature engineering to training, tuning, and serving, and a lot of stuff. And if you need to have different system for a different step, your system will be very, very heavyweight. And so, for example, for some existing solution, you may need to launch like a 10, maybe 20 or 30, like something like that, pass that on your local Kubernetes cluster to cover the end-to-end life cycle. So it is pretty heavyweight. But if you use Ray, you just need to launch 2 pods to start that. You just need to launch one Kubernetes KubeRay operator pod and one Ray hat pod. And the second is that because in the microservice architecture, because your different stage in the model lifecycle are not totally designed together, so you need to have some way to glue them together. For example, if you finish the data processing, you need to know how to communicate with your training process. So user need to do a lot of stuff like building a Docker image and write a lot of YAML file, or use some workflow architecture like Airflow or Flight to glue all of the different stages together. So, but data scientists, they don't want to handle anything about infrastructure. And the third one is that because I think the AI application changes rapidly, so this kind of complex infrastructure is hard to fulfill your new infrastructure requirements. Yeah, so I think currently I think Ray and KubeRay is the most popular solution that's on the Kubernetes to build the AI infrastructure solution. And as I told before, different workload have a different system requirement. For example, like if we want to use the data person, we need to have like the GAN scheduling. But if we use like the online service, we may want to have the auto scaling because we cannot predict how many requests we will receive. And we may want to have the high availability. So the different stages have the different requirements. And we can also focus on the single stage, like the model serving. It is also different. For example, before the large language model, most of the model serving you can run on like a CPU or a single GPU because the model is small. And most of the case, the bottleneck is about the computation. So the goal at that time is that maybe we want to figure out how to reduce the number of the floating-point operation. But for the large language model, because the model is very large, you need to have multiple GPU to serve the model. So the question moved from the computation bottleneck to the memory bottleneck. Because it is very large, and the large language model is based on the transformer decoder architecture, and it has some auto-regressive nature. So it is a memory bottleneck. So I think in the past 2 years, I see the workload move from like the deep learning, reinforced learning, stable diffusion, IOHF, and the large language model, MOE, and multimodal, a lot of stuff. So different workload has a different requirement. So you need to have a flexible and future-proof AI platform. Yeah, and this is an example to showcase that how powerful is the unified AI runtime. This is a very simple example. This is from Samsara. And you can see before they adopt Ray, they use microservice. The first is that they have the Golang microservice for model selection, and then has a Python microservice for the inference. And then use a Golang microservice to do the business logic. And then they decide to use Ray core, Ray serve and Ray core to make them work together. So it can save the cost of like the deserialized and deserialized cost between the different microservices, and they can share the resource between the stage. So they achieve the 50% cost reduction. And for more detail, you can see the Samsara engineering blog. Yeah, so currently we know the Ray core, Ray AI library, and the KubeRay. So currently we can talk about the demo. And here today we build a demo is that we build a large language model chatbot, and we have already pre-processing some of the Ray documentation, store them into the vector database, and we will do a RAG with the Ray documentation, so we can ask some Ray question that to the chatbot. And this is the best LLM. We have a query sent to the, we enter a query that's in our web application, and send a query to the model and get a response. And response also shown on the web application. And with RAG is that we have already stored some embedding of the Ray documentation in the database. So when we send a query, we will at first to generate an embedding for this query, and then use the query to search the most relevant context, and then we will append the context that's on the query, so it can get a better response. Yeah, so I will talk in more detail about this demo. The first is that we generate the embedding using Ray data. And we also published a blog that's about how to generate a 10x cheaper embedding with Anyscale. Yeah, and you can see, I think this is very informative and very welcome to read it. And in that, what we do is that we use the Ray data and we split it into multiple chunks and use the GPU to generate the embedding and store it into the vector database. And the second is the retrieval. When we have a query, we will first generate embedding for the query and try to do that something like cosine similarity to get the most relevant context from the database. And the third is that we will also put both the context and the query and send it to the model to get a better response. And in this demo, we use the Anyscale endpoint as our large language model backend. You can also deploy with like our open source project Ray LLM. Yeah, and this is the I will build two demos. The first one is with Anyscale, and the second one is with KubeRay. Yeah. Let me share. Okay, cool. And this is the Anyscale workspace. And you can see the first is to initialize the vector database, and this is the a notebook that's on the Anyscale platform, and we generate embedding that with the Ray data and store into the database. Yeah, and we have already finished the embedding generation, and now I check my Postgres database. Yeah, and I think we can find out the and then we generate the response, and we can see. Yeah, I think here is the response. This is the question, and this is the context that we retrieve from the database, and then this is the answer. And then we will verify the answer later. And then this is the KubeRay demo. Yeah, because we don't have the notebook, so I just run the Python script directly. We can see this is also embedding generation, and check the database, and get a response. Yeah. Because the model that we set the temperature to 0, so we will get the same answer. Yeah, and then we can verify the answer. The question is that what is the default batch size for batches? And this is a question about one of the Ray data function. And we can see we get the top 5 contexts, and we see the first one. The first one is here. And we can see, the batch size is actually 1024. So I think the answer is correct. Yeah, and there are some for reading. One is our blog, and the other one is the demo of this video, the code of this video. Yeah, and cool. Thank you, guys.
KubeRays demo. Any chance you can just come back to that cluster to see what components are running in the cluster?
So which one?
You go to the cluster view, the Kubernetes cluster view.
Kubernetes cluster view?
In the demo, actually, sorry.
Oh, in demo?
Yeah.
Is that this one?
Yeah, that one. The one
Yeah.
Exactly. So I'm trying to understand, obviously some of these are standard Kubernetes, but what's things like connectivity agent, could you just walk through what some of those components are and what function they're serving?
Okay. Also, you want to know more detail about how does it work? You can see like this one is, I think this script is for the embedding generation, and at first is that we will load the Ray documentation into our memory, and then we will divide it into multiple sections because it is a markdown. And then we will use some chain function to split into multiple chunks. And then we will use the Ray data to do the embedding generation. And then when we finish the embedding generation, we will write into our Postgres as our vector database. So this is the embedding generation, and then this one is that we check our vector database. Yeah, and I think this just maybe 0.5 seconds, but you can see that it's successfully stored into the vector database. And then we run another Python script is about inference. And the inference is that, at first is that we will send the generate embedding for our query, which is our question is that what is the number of the batch size, and then we generate embedding for it, and then we send the embedding to look at like the most relevant context from the Postgres, and then we add the context to our query, and send it to our Anyscale endpoint, and our Anyscale endpoint we use the model is the Mistral. And this is the answer. And because both Anyscale demo and the KubeRay demo, we set the temperature to 0, so the answer will always be the same.
That's helpful. The follow-up question on that was, it looks like all of this is running in a Kubernetes cluster, so you have an operator that's managing all of this. Have you looked at going across clusters, presumably via ingress or ingress gateways? And from a networking perspective, when you have actors talking to each other across clusters, what sort of performance and latency elements come into play?
Got it. But honestly, I think it depends on your model backend, because I think you can see here that we don't do any inference computation from our side. We just do that from the retrieve the context from the vector database. So the first is that I found that it spent a lot of time on the retrieve the context from the vector database, and because I don't spend a lot of time to find the hottest optimization configuration about that. So I think maybe another speaker can talk about that it later. And the second is about your large language model latency. So I think these two very depends on like your different model and different model and the different vector database. So at this moment, I think currently the main time that spent is not from our side. So I think currently I don't have an answer. So I think it depends on the database and the endpoint that you use.
Other questions? Okay, in the back. I'm gonna bring a mic and I'm gonna hold another mic to record this.
Okay. I saw you how it integrated with the Python scripts in that one slide there. I was just curious, like, depending on the platform you choose, like you mentioned you can do to a local cluster, or there's a couple cloud platforms where you can do Kubernetes. Do you have to change like how you write your Python code? Like, would the data scientists have to think about the platform they're on when they're writing their code?
I think it depends on. I think in most cases that you don't need to worry about that, but in some cases that you need to understand it. For example, if you want to serve a model and across multiple AZ availability zone, and I think like in the VM or in a different configuration, you need to try to find a way to tell the Ray that these two different, maybe these three different array paths belong to a different AZ, so that you can schedule it correctly across multiple AZ.
Okay. And how did they specify memory requirements and things like that?
You say for the test and actor?
Well, when they're writing their Python script, like
Got it.
how are memory requirements, resource requirements, things like that specified?
Got it. You can see like here, there's annotation, and there's @ray.remote. And you can specify the memory or CPU, something like that here. But in array, the resource is the logical resource. We don't do something like a C group. So we specify the memory or CPU, just promise that they will have at most this kind of the test or actor be scheduled. But we don't do like a resource isolation between the different Ray test or actor.
Okay, I see. Could there potentially be issues because of that, or do you deal with it somehow? Or is it just up to the operator?
I think it depends. I think the first is that if you want to build like the user C group, I think there will maybe some new overhead, and but at the same time is that if you don't really understand like your workload, how many resources it uses, maybe sometimes it will have the resource contention, something like that.
More questions? I'm in the back, so please raise your hand so I can see you if you have more questions. Okay, I see a hand there. By the way, I just found a lot of beer in the corner. If you guys need more, is that right there? Sorry, who held the hand up, please? Yep.
Sorry, I'm up here.
Oh.
You can go ahead.
I think in the whole pipeline of doing MLOps, Ray can be used in multiple places, but I'm interested in training. What are some of the setups that you see companies are using in production? Do they use the same node with GPUs provisioned by cloud providers, or do they change that to run on premise and then serve them on cloud providers because of cost?
Got it. I think the first is that I would say that most of the people start to find the GPU from different cloud, not only like AWS, GCP, or Azure, but also like something like a Lambda Lab or CoreWeave, right? Because I think the GPU scarce is a very important question, and but I still don't see like the multi-cloud at the same time, like the same cluster, multiple cloud. And the second is that for the on-prem, I would say that I never see that who moved from the public cloud to the on-prem cluster. From my personal experience, maybe on some social media I see that, but from I keep in touch with maybe 100 of companies, but I never see it. And the second is that I think people start to explore the new accelerator. For example, like the TPU. And like the AWS like Inferentia and the whole or Trainium, I recently see more and more people to find it. And the second is, and the next question is that there are some multi-host. A multi-host is some a concept like in GPU and the TPU both of have a multi-host. It means that you have multiple versions of the TPU or GPU, and each of them connect with the high-speed interconnect. Yeah, so I observed the trend, but honestly I think the multi-host is a pretty new stuff, and it is not very well supported in the Kubernetes or in Anyscale at this moment. It is not that easy to use, so we collaborate a lot with like the TPU team and GK team to make it work. I think it currently works in some stuff, yeah. So I think this is a trend that I observe.
All right, we had a question in the front, so I'm bringing it to you.
Can you go to the step where you describe embedding models? I think it was Ray data. I think it was step 1 or 2 or something like that.
This one?
Yeah. What kind of embedding model do you guys use? Is it specialized to any context? Can the user change it to their own embedding model?
Yeah, I think they can change the embedding model, and we have a blog that like published by our colleagues that they do a lot of experience about like a different different chunk size, different embedding model. We do a lot of experience and write a summary that to see the relationship with the quality of the response. Yeah, but here I don't spend a lot of time to change the embedding model.
Thank you.
Or I guess last question for our first speaker. Anybody? Yeah.
Hi. Yeah, I had a question about running Ray at scale. So for large node clusters, a common problem is Ray actors dying unexpectedly. So I was wondering, have there been any updates to Ray core to kind of mitigate that more? And the second thing was also about utilization of the Ray client. As you might know, there's a lot of new tools out there like CodePlayer who give you the ability to abstract away the Ray client as a result of issues like serializing and deserializing as you push code from your laptop to the cluster. And so I was wondering, what steps have you guys been taking to address those so far?
Got it. I think for stability issue, I think in the past 2 months, we also invest all of the recording in the stability stuff. So I think you can see it's become much more stable in the past few releases. And for the Ray client, I think because of some stability, there are some technical issues that it's very hard to maintain it. So currently, we don't recommend the user to use it. But I think we still observe a lot of users pre-like it. So we may revisit it. But I think at this moment, we don't have a plan. But we have some design doc that's in our table. But currently, still in discussion. But I think because we receive a lot of signal about user pre-like it. So I think after we fix some of the stability, improve the signal. I think because currently our PD role is the stability. We spend a lot of time on it. And maybe after that, maybe we will revisit it. But currently don't have a plan.
Oh, thank you.
All right, let's thank Kai-Hsun Chen. Thank you very much.
Cool, thanks.